Hello, welcome to the electrical engineering class. Today I want to share you some fundamental and basic control circuit for low voltage induction motors, which is widely used in any industries. In this video, I'm using Japanese power supply and Japanese product, but the standard of electricity vary depending on the country. So please consider this video just as an educational reference. So let's get started. So this is a Mitsubishi 3-phase squirrel cage induction motor, which rated voltage is 200 volt and capacity is 0.2 kilowatt. It's kind of a small one. And this circuit is for controlling this induction motor by using some basic principles, which I'll explain with this course. So let's see the actual operation procedure of this circuit. When I push this long button, motor starts to rotate like this, and even if I release the button, the motor keeps rotating, and this shining red light indicates motor is running state right now. If I push this stop button, motor stop, and this white light indicates motor is stop state. And here is a wiring diagram of this circuit. So let me explain how this circuit works and roles of each component step by step. So in general, you can see our circuit diagram from top to bottom and from left to right, basically. So the first component we can see is this switch, this one. This switch is a circuit breaker that connected to a power supply directory. In this case, a 3-phase 200 volt 16 Hertz. Let me check by multimeter. $200 volt and 200 volt almost. That's fine. Circuit breaker is a device, just as the name implies, which can interrupt the circuit. Basically, they have two main functions. One is just mentioned, the switching function. It's kind of intentionally disconnection. So when you need to the maintenance of this circuit, or expansion, construction, kind of that, you can isolate this section from power supply by switching off. So when on state, the secondary side is 200 volt, 200 volt, and 200 volt almost. It's the same as the primary side, just as I mentioned, I checked. But off state, it's 0 volt. Yeah, almost 0 volt. It's 0 volt. So interrupted. You can confirm the state of circuit breaker by using multimeter or resistance range, even if not connected to a power supply. This is the same circuit breaker. At on state, the resistance is each phase 0 ohm, 0 ohm, and 0 ohm. Of course, it's closed, but the off state, it's open, so the resistance is infinity. Each phase right? And the second function of circuit breaker is protection for failure like short circuit or overload, or sometimes ground fault. It's kind of unintentionally disconnection. Circuit breakers are one of the most commonly used element of protection system, and each breaker have a rated trip current, in this case 15 ampere. So when load current which flow circuit breaker reaches or exceed each rated current, in this case 50 ampere, the breaker cut off the circuit for protection. So I'll explain more details of function of circuit breaker, including arc leakage one, and how select it when you designing some electrical circuit. That may be another video. Actually, it's not so simple. It's complicated when select a breaker. It's very depending on load characteristics, types of factory, consider importance or safety, kind of that. So please check it if you have some interested in the precise explanation of circuit breaker. I upload the video soon, maybe. The next device are magnetic contactor, this one, and thermal protection relay, this one. I have a same rated one respectively, and they have the magnetic contactor have a open and close contact with electrical magnetic force to switch. Let me explain the actual. So they have this is normally open contact, and if I push this switch, it's turned to short circuit, it's closed. On the other hand, they have a normally closed contact, and push this button, it's open. All right. And they have a coil terminals too. These two terminal connected to the coil, and when coils are energized by applied rated voltage to this terminal, the coil turns to electromagnet, and just I mentioned, open and closed contact will flip their state. That means open contact will turn to close, and closed contact will turn to open. So let me show the practical motion. Alright, be careful. Alright, so let me try to the actual motion of magnetic contactor. I try to apply rated voltage to the coil terminal by supplying from primary side of 200 volt. Alright, 3, 2, 1. It's energized like this and de-energized. Right? It's a little bit dangerous, so let me stop and be careful, don't short circuit. Alright, and the thermal protection relays have this thermal protection relays have a closed and open contact, same as a magnetic contactor, and when the load current exceed its setting value, in this case, this is a 2.1 ampere. So if the load current reaches the 2.1 ampere, each contact will flip, and in this case it's a normally closed contact, so this contact will turn to open circuit. So in the diagram, this is a detective section of the load current, and this is a contact which vary depending on the condition of this detective section. Alright. Thermal protection relay have a test button, this, for operating check. So let me show you the actual operation. So this is normally closed contact, but if I push this test button, it's turned to open. It's the same as the actual operation of the thermal relay. And if I reset this reset button, it's reset, so it's turned to the original state. And the setting value of the overall current be adjusted by this potentiometer. Now it's to 0.1 to like 1.7 or more, 2.86 or kind of that. We need to set appropriate value for fitting each load characteristics. So we needed to design such each value. I'll explain about more detail of thermal protection and magnetic contactor maybe another video, so please check it if you are interested. The next component is fuse, this one and this one, but my apologize, I don't have a appropriate fuse to fit this fuse holder, so I just make a short circuit by using bridge wire. So in fact there are no fuse in this circuit. Sorry. So use this another example. It's a very small one. Fuse is also one of the most commonly used element of our protection system, especially for control circuit. They disconnect the faulty circuit if the current reaches a predefined value. And speed and cost are the main merits of fuse. On the other hand, their drawback is that they cannot be reset, so they need to replace totally after each operation. It's a little bit too hard to see, but a very slight wire is inside. So it's conducting state. Let me check the resistance range. Yeah, it's short. But if some failure happened, it's interrupt. Alright. The next device is a relay. This one. In schematic, this is relay coils and relay contact. Relay's function is almost same as a magnetic contactor. They have a open and closed contact with electromagnetic poles to switch. So they have a core terminals, same as a magnetic contactor. These two terminals is core terminals. So the core terminals is energized by applied a rated voltage. The coils turn to a magnetic magnet, and each contact will turn to flip the opposite state. So yeah, this coil terminal, applied 200 volt. This color is excited, and this normally open contact will turn to close, and this normally closed contact will turn to open, and let me show actually the relay. When the relay is energized, it's like thrusting like this, and the magnetic contactor is it's dollop in this part. All right. Sorry, it's a little bit noisy. The next device is momentary push button. This one and this one in the schematic. These two devices. They have an open and close contact respectively. That one has a normally open contact, and green one has a normally closed contact, And while you are pushing the button, state or each contact will be flipped. I mean, normally open when you pushing. While you're pushing, it's turned to close, as a close and open, close and open. On the other hand, the normally closed green button, while you're pushing, it's open and back to close, open and close, right? The last device is signal light. This two one. It just will shine when a rated voltage are applied each device, each terminal. Yeah, that's it. It's very simple device. So let's see the operational procedure again, more precisely with wiring diagram. Motor is a little bit noisy, so right now it's interrupt. Just now. So the main circuit breaker is off like this. Nothing will happen because electricity are hold up till this. So in the schematic, electricity are hold up just this. So let us turn to breakers on. Electricity can pass through until this portion. I mean, circuit breaker is on, so electricity pass through these terminals. But magnetic contactor is still off. So to stop this part. At control section, electricity are stopped with its conducting. So this is normally closed. I mean, this is normally closed, so electricity can slow it. But this is normally open. This is open, so electricity stop this version. And this relays normally open contact. It's also open, so electricity stop this terminal. And the same as this relay is normally open, but this relay is normally closed, so electricity can pass through, and white light is energized like this, so it's shine and back to the other phase. It's a now. So what happened next? I will push this normally open on button, run button. It's something change. Alright, this start state will turn to close, so LXD this normally open contact will turn to close, so LXD can pass through this contact, and this is a summer normally closed pass and it's closed, so through, and this magnetic coil and this relay coil is energized. Alright, so the magnetic coil is magnetic contactor's coil is energized, so this normally open contact is turned to close, like this. It's close, close, close. So it's turned pass through to the load. I just interrupt right now, so there are no load. And this relay coils are excited too, so this normally open contact is turned to close, so electricity can pass through this, and this normally open is turned to close, so this LED light is energized and bright like this, and this normally closed contact is back to the closed state by energizing this relay coil, so this white light is de-energized like this, back to the sorry, it's turned to open. All right, sorry, it's a little bit complicated. And so the point is, it's very interesting. This is momentary push button, so I release this button, it's turned to the open, open close, but I release the button, it's turned to open, back to the open. So it's normally closed, contact is turned to open again, but these two coils has a still energized, keep to this state because of this route. I mean, this connection is a relay coils, normally open, but it's energized and turned to close, so this can still, even if this push button turned to open, but it's still this route makes magnetic coil and relay is energized. Interesting. It's called a self-holding circuit. It's very important in this control circuit analysis. And if this stop button, of course it's stop, because this stop button is this. If this normally close button is turned to open, it's open, so electricity is stopped. Hold up this and hold up this, so it's all it's all is hold up, and this normally close is open, but back to this de-energized, so back to closed, so it's the white light is energized again, but it's normally open, it's turned to open, so it's de-energized, that light. Sorry, it's so messy. So this is a supplement for, in this video. Here is a typical residential home in Japan, and we don't have a three-phase power supply. It's just one phase, single phase, and just 100 volt. 100 volt is most commonly used in Japan. So I create the three-phase 200 volt by using this inverter. It can convert from single phase 100 volt to three-phase 200 volt. You know, it's so helpful. I always appreciate the technology of this whole world. So thanks so much for watching this video, and next video I will share you about how build this practical circuit from wiring diagram, and troubleshooting of motor control circuit like today's one. So see you next time. Thank you for watching. See you next time.